Now let's learn about a new data type called the tuple. Tuples, for all practical purposes, are a lot like a data type we already know, the list. So as the English teachers would say, let's compare and contrast. First, we'll make a list. Recall that we can make a list by using square brackets and just typing out the numbers or other objects that we want, separated by commas. So here's a list that has 3 objects, 2 integers, and a string, which happens to be string. And we'll make a tuple with the same elements. And the way we create a tuple is with parentheses. So the setup is almost identical. We can access the items in the tuple in the same way we access the items in the list. So for instance, we can say print my tuple, index position 0, which would be the first item in the tuple. It's exactly the same as print my list, index position 0. The big practical difference between the tuple and the list is the tuple is immutable, meaning it can't be changed. We can't make it bigger, we can't make it smaller, we can't change the items inside. Let's try. We know we can change the items in my list by using the assignment operator. So if we want to change the string to something more interesting like gadzooks, we can print out the object at that position. But with a tuple, we can't do it. We get an error. It says tuple object does not support item assignment. We just can't change anything once the tuple is established. We'll find that we also cannot append the tuple. So if we try mytuple.append to add our exclamation onto the end of the tuple, there's no such method. It doesn't work. So we can't change the tuple. Some interesting result of that is that if we copy a list, so we can say my other list equals list my list. In other words, we're passing a list to the constructor for the list object. We're creating a new list, and then we print the ID of my list and the ID of my other list. We find they're different. These are actually 2 different objects. The reason they have to be different is that if they weren't, and I changed an element of my other list, it would also change the same element in my list. Definitely not what we want after we copy an object. But let's try to copy the tuple. We definitely have a tuple constructor. And we find this actually works. And if we look at the 0 position of my tuple and the 0 position of my other tuple, we find that we did actually make a copy. In fact, we can print out the whole tuple and see that one is a copy of the other. But the surprising thing may be that they aren't actually copies. You remember with the list, we got 2 different IDs, but with the tuples, we get the same ID. And the reason is there's no way to change my tuple. There's no way to change my other tuple. So why create 2 totally different objects if they have to remain exactly the same? So both of these names point to the same object no matter what. We'd often use a tuple if we're trying to return several values from a function. Let's create 2 lists. So we have 3 runners named Spike, Sammy, and Sally, and they run a race, and the race times are in another list. We might create a function that picks out the winner. Our function takes 2 lists. One list is entrants, and the other list is their times. And these lists should be the same length. We're not going to check that. But we want to go through and find the best time. We could do that with a sort of complicated loop, but there's another way we can do it. We know we have these functions like min, max, sum. We'll use min to find the smallest time from the times list. Then we're going to use a method of the list class, and the method is called index. Index takes an argument that is an object you're searching for in the list, and what it returns is the position in the list where it first finds that argument. It's not perfect for this example because if we had 2 runners with the same best time, we'd only get the first one. But we'll go with that for now. And then we're going to return the entrant and their time. So we're using the result of the index method to identify the runner and their best time. We'll call this function with the lists that we've created and store the results in a name called results. That's fine. Nothing happens because we didn't print anything out. But let's print out our results. We get the runner and her time, just as expected. But this is interesting. There are parentheses around those values. That looks suspiciously like a tuple. Let's find out. And it is. So if we return multiple values from a function, we get a tuple. And we can actually expand that tuple in the assignment. So instead of assigning the return value to results, we could assign it to runner, time, and the right values go to the right places. Okay, let's summarize. We have two data types we're talking about, the list and the tuple. The biggest difference is that the list is mutable. Mutable means changeable, so the contents can be changed, and the list can be appended. We can also shrink the list by deleting items. And a copy of a list is a distinct item. The tuple, on the other hand, is immutable. The contents are fixed. The length is fixed. And a copy of a tuple is the same tuple. Of course, they have some things in common also. They can both contain mixed data types. And access is the same for a list and a tuple. So we can use indices, and later we'll see slicing on both the list and the tuple. So why bother using a tuple at all? There are three primary advantages that tuples have over lists. The first is that tuples are read-only. That's just another way of saying they're immutable. But if you have a collection of data that you know is never going to change, why not make it a tuple? Then we can't change it by accident. It makes debugging a little bit easier. Another advantage is space efficiency. Because lists can be appended, and it's kind of an expensive process to make a list bigger once we have it established, Python actually reserves some extra space just in case you decide you want to make your list bigger. So a 3-element list is going to take up quite a lot more memory than a 3-element tuple. And then finally we have time efficiency. Tuples can be slightly faster than lists for a few reasons. One of them is that since the interpreter knows you can't change a tuple, it can look ahead in your code and see if there's any math that it can do ahead of time. For instance, if you're multiplying two constant values from two different tuples together, the interpreter might as well do that before you run the program because it already knows the answer is not going to change. That's called constant folding. Another is the depth of referencing. A list takes 2 steps in memory to get to the actual information that you want to retrieve, while a tuple only takes 1 step. And finally, a list object is created every single time you ask for one. Tuples are reused, so if you had a tuple 1, 2 that you then deleted, Python reserves this space in memory for a 2-item tuple in case you come back and want another one. That saves a little bit of time when you're creating the object. Most programs use a combination of lists and tuples.